Hello, good morning. Welcome to the next part of the introduction to Unity series from scratch. It's a new day. It's a morning. I put on the same shirt so the videos are consistent. Definitely on purpose. This video is the rollerball video. So this is your first script in Unity, perhaps. This is our first project where we're going to make something interactive, perhaps. I'm going to assume you know a little bit about programming. Maybe you've done some Scratch or some Python courses. Maybe you've done some hour of codes or hackaday things. That you know what a variable is, you know what a function is, or at least the idea of it. I'll go over some C# syntax as how it differs from other common languages, but I won't be introducing these concepts from scratch. So that's where we're at with that. I'm also assuming that you've seen a lot of the interface and layout videos that I've put up or elsewhere, and we know about scenes, game objects, components, and assets. We may not know how exactly to use them. Enter this video, but we know what those things are. But hey, let's recap anyway. Scenes are three-dimensional spaces and lists of our game objects. Most of our Unity editor is dedicated to editing any one given scene at a time. And we can have many scenes in a Unity project. Our hierarchy is a list of all the different game objects in our scene. Game objects are anything that can do anything in our space, in our scene. What makes one game object different from another are its components, like camera or light or mesh renderer or any of the audio source, any of all the different behaviors that something in our project could have. And our components use properties that we edit with numbers, usually colors, which are, red, green, blue, alpha for numbers, or references to assets. And our assets are just files on the hard drive. So anyway, we're in Unity. We're going to make a ball that we can roll around and we can control ourselves. So the first thing we're going to do, and if you're coming after the last video, you may already have this. First thing we're going to do is to make a ground for our ball to roll around on. So we're going to make a new cube. Again, to make game objects, we can right-click in the hierarchy. We can click the plus button in the hierarchy, or we can click the game object window. This all brings up the same menu, and we're going to make a cube. And I'm going to call it floor. Right when you make a game object, it will let you name it. Just tap escape to get out of that. Or you can always rename it in the inspector. So we have a box collider. That's all we need. Let's position it at the scene origin, because that's a good place to put the middle of our scene, and we'll scale it out. We'll scale it out so it's a big ground that we can roll a ball on. Let's make a material. Of course, before making a material, we need to make a folder to put our materials in, because we're going to stay organized, because we're not monsters. So right-click in the project window to create various assets that Unity has. We'll start with a folder, and then inside of that, we will make a material. For ground, I don't know. And we'll make it like a grassy green color. Sure. Why not? Next, we need our player. So we're going to make our player is going to be a very simple sphere. That's it. And we'll position them at 0, 0, 0 as well, except then they're like inside of the ground. So we need to move them up. Let's go ahead and just make that exactly 1. Because the cube is 1 unit high. The sphere is 1 unit in diameter. So if they are 1 unit apart, they will precisely measure. So player is now resting on the ground. I want a material from my player. I'll select this material and hit Control D to duplicate it, remembering not to use that keyboard shortcut in Windows File Explorer. And then we'll make the player, I don't know, purplish. Someone will stand out against green. And that's it. Let's rename our player to player. Player. So we're going to roll this player around. We need to have the this player object be part of the physics system in Unity. We're going to be adding forces to it that respond to our input. We need the game object to be able to respond to forces. So in order to do that, we're going to give it a component called a rigid body. You can find it in the menu when you click this add, select the player in the inspector, click the add component button. There's a menu here behind my head. I've never seen any Unity developer ever use it, so everyone I've ever met always just starts typing the name of the component they want until it pops up. We're going to use rigid body. There's two rigid bodies because there's two physics systems built into Unity. These two physics systems are separate. They do not talk to each other. Components that are built for one cannot be used in the other. One of them is a three-dimensional physics system. The other one is a two-dimensional physics system. This is a 3D game. We're going to use the 3D one. So we're going to ignore any of the settings with the 2D at the suffix, or vice versa if you're making a 2D game. So now, actually, let's raise the player up, do exactly what I said not to do, just to prove a point. It falls. Now that the rigid body is responding to gravity, which exists in the scene by default, adding a force to the game object, it is moving it, and the player's Y position has changed. If I leave play mode, teleports back to where it was when I entered play mode. So entering play mode began the game. It began, the physics system started simulating, the rendering system started rendering the graphics, and everything happened. My scaling is off, but that's because my Windows scaling has been messed up so that the interface is nice and big for this video recording. You probably see that as a 1, and that's probably fine. Okay. There we go. You should be able to see your player if their X and Z positions are at 0 and 0, so that the main camera is pointing at them. But we'll move the camera around in a bit, but I'm going to move on for now. Let's put that back on the ground. And now we need to make a behavior of our own, the actual meat and potatoes of this video. So this, up to this point, was just you getting set up to be able to follow along with me. Now we're getting into the, writing our first script. So to do that, we're going to make a folder to put our scripts in, because we're not monsters and we're going to stay organized. By default, just capitalize in plural your folders, and then as a starting way to organize before you come up with the systems that you're going to use, organizing by the type of asset is pretty good. In the future, you might be changing that, and maybe you'll have, textures, models, animations that all relate to one character 3D asset together, and that would make sense. But for now, we're just going to keep everything separate by what type of file they are. Our scene files, our material files, which are just these .mat files. Actually, you can see what they look like. It's just a list of all the settings that we've set that you can edit in the inspector. Okay, I digress. We've made a scripts folder, and now we're going to make a script. So that is an asset. It's just a text file. It's just a plain text file with a .cs suffix instead of a .txt suffix, but it's just a plain text file. And we can make it from Unity, which will add some boilerplate code for us. I'm not going to make it yet because there's something special with the naming. But before I talk about that, I want to talk about the different types of different languages that Unity supports. Unity supports 3-ish, 4-ish languages, depending on how you count visual scripting. We're going to ignore, this video is not about the visual scripting system that Unity has added. It supports 3-ish languages. Modern versions of Unity, 19 and above, is C#, period, end of story. Unity used to also support JavaScript as a language, and it would recompile the JavaScript into, I think, C++. I don't remember, into one of the .NET languages that Unity's built on with Mono or IL2CPP, integrated language to C++. Anyway, it would recompile, it would just convert your code, and it was slower and less performant because it had to do that conversion process. But the advantage was if you knew JavaScript, which at the time was a very popular teaching language for programming, now Python has taken over, it was easier to get started with programming, but it was missing a lot of the features that C# had because of that recompiling process, to my understanding. I never wrote in JavaScript. My point, the reason I bring this up is because if you go online and you see JavaScript in the documentation, or if you go to the online documentation and you see a toggle that lets you switch between different languages, you're in some out-of-date documentation, and that's surprisingly easy to get to by Googling. The last language is something called Unityscript, which was like a fork of JavaScript, I guess, that had a bunch of syntactic sugar to make life in Unity easier. I don't know. No one ever used it, to my knowledge. It was one of those things that started when Unity was like more for education and more for like kids, where it was like, oh yeah, we're gonna make this kid-friendly thing. And then now Unity's not, well, it's still targeting an introductory audience, but it's has a much larger percentage of its user base are professional game developers, and that's a lot of where Unity, the company's money comes from, is supporting those customers. So spending a lot of resources making Unityscript not a high priority, especially because Python has taken over as the introductory language that we're teaching everybody with, not JavaScript. So supporting that's like less helpful than it used to be. Okay, that's my understanding of things. I don't know anything about the insides of Unity. I've always used C#, even back when those other options were available. You know, I might be wrong. I might be off the mark on my understanding of that. When we create a C# script, it gives us a chance to rename it. This is very important. We need our class names and our file names to match. What's a class name? Stay with me. Our class names is a program, is a C# thing. Which means we need to name our script files with the same naming convention and the same standards that we name our variables, our classes in C#. And we don't know what those are yet, so I'm going to tell you how to name your files. No spaces, can't start with a number, and we're going to do uppercase camel case, or no, that's camel case, uppercase Pascal case. You're going to, no spaces, full words, capitalize every word. So we're going to call ours player movement. So it's a capital P, player, capital M, movement. No spaces. Okay. And then we got this little Octothorpe icon. The hashtag you might know is the pound sign or number sign. If you enjoy symbols, you might also enjoy that is called an Octothorpe. It's got 8 little pegs. Okay. If you double click on it, it should launch in your IDE because you've gone and followed my other guide on installing and setting up. The one thing that I think a lot of people forget to do after they get everything set up is to choose the appropriate IDE in this preferences, edit preferences, external tools, external script editor dropdown. We don't want file accessory. We want the actual tool because that's going to make sure everything's nice and connected. It's going to mean when we double click on a file and open it, the cursor is going to go to the right line, and the project is going to open the appropriate solution file, whatever that means. Okay. So here is our code. Up top, we have some using statements. These are importing libraries, using Unity engine, using all the code and scripts and libraries, things like mono behavior, whatever that is. We need to tell C# that we're going to be using their stuff, things like vector3 and rigid body and so on. So we need that. It also includes using system.collections and system.collections.generic, which are the C# libraries that include lists. And those are important, and we use those all the time. So Unity has the boilerplate code include those statements as well. You can see that my code editor writer has grayed them out because I don't have any lists or any functions that are in those libraries. So it's like, you don't need to include these, but I probably will. We're just not going to touch that. Next is the class declaration. I am creating a class, a definition of a type of object. And it extends mono behavior. I know I just said a bunch of weird words. But I think it's important, you know, even if you never actually create your own classes or declare them or memorize the syntax, I think it's important to know what this line of code does. I am creating a definition of some kind of thing in C# called player movement. And the type of thing that I am creating a definition of is a mono behavior, which is Unity's internal term for component. I'm taking some liberties with that, but for us, pragmatically speaking, the fact that it's got this colon here means that this is going to be a component that we will be able to add to our player. So take a look at this. I can go back to Unity. I haven't run any code yet. I can go back to Unity. I can drag and drop my script onto a game object. And in order for Unity to do that, two things need to be true. One, this needs to extend mono behavior. You know, if that didn't, this is gonna break. Or yeah, it just totally broke. Got some errors, we'll fix that. And the second thing that needs to be true is that the file name for this asset, which has that internal GUID, that identifier, this file name is how Unity knows what asset is connected to what class. Because in C#, C# doesn't care about files at all. You can write all of your code in one giant file. Don't do that. That's insane. But you could. You could write all your code in one giant file. So the actual files, as far as how they represent a script or how they represent an individual component, that's something that C# doesn't care at all about, but something that Unity does care about. So Unity is going to enforce that we use one file per class, which is also a standard C# thing that most C# developers do anyway. And it's going to enforce that we use one file per class and that we keep the file name and the class name matching. That way Unity can find the connection. It says, okay, you have this file, it's got this name. That means after C#'s been compiled, it can go and it knows what code that we're talking about. Because C# doesn't care, doesn't know about any of that stuff. It's ambivalent to your file structure until you get into assembly definitions. But there's always an asterisk, right? There's always an exception to what I'm saying. We're going quick. But we haven't written any code yet. I'm giving you the explanation that I wish I got when I was starting with Unity, which is to actually, instead of just say, yeah, make it match because I said so and wave my hands, it's to actually tell you why it's like that. It's for good reasons. Because now you know that if you make another class, that's probably fine. But if you make another class called mono that extends mono behavior, it's no longer fine. It doesn't know which one to reference. Okay. So programming is strange and ugly and bad and gross and terrible, but it's also kind of amazing and beautiful and wonderful and awesome in poetry. So why do I hold both of these things to be true? Because programming is for two audiences. Programming is for computers, programming is for humans. We need to write something that can be read and understood by two very different audiences. And the messiness of that, of the compromises that come from that, is a lot of why programming is so difficult. Because we need to write all sorts of strange specific symbols like these curly braces and the colons and the, all sorts of weird little punctuations that is very nice for computers to help it sort of parse and understand what it is being written here. It makes it really difficult for humans to read because it doesn't read like a sentence, right? You've spent your entire life learning how to skim past punctuation. Your brain has been trained not to look at punctuation. So don't feel annoyed and frustrated, if you have a bug where you're making an integer and you forget there's a semicolon that needs to be there at the end. You forget it. It's very easy to not even see that that's not there because your brain has been spent your entire lifetime of reading not looking at semicolons and just breezing past them. Computers, on the other hand, they love looking for semicolons. They use all sorts of strange symbols. A lot of the reason that computers use symbols that we don't use commonly is so that it frees up the alphabet and words that we do use commonly to be used for like variable names and the names of things that are more for humans as opposed to the parts that are more for computers. Gosh, I hope that made sense. I kind of lost my thread, but programming is a compromise between computers and humans. There are a lot of affordances that I need to make for the computer. I need to write all these weird symbols. I need to be very specific in ways that feel unnecessary. I need to talk about types and all sorts of things that are me, giving something to the computer in order for the computer to better understand it, and vice versa. There's going to be a lot of times you write inefficient code, or you write code with ridiculous variable names that are the computer doesn't care. It's giving you that so that you can understand it. So programming is in this middle space, and that means it's hard and weird. So let's write some code. So we've created a class called player movement. We only have one class per file, which means we're going to write all of our code inside of these little curly braces, these little mustaches. So go ahead and find that symbol on your keyboard and make sure you know how to get it. It's right to the right of the P key, to the left of the backslash, forward slash, backslash key. And you're going to be using that one a lot. When you type the opening one, Writer probably types the closing one for you, and so does Visual Studio Code, and probably so does VS Code, and probably so does Sublime Text 2, whatever IDE you're using. So we have these. These are, I guess, the most important thing to learn about programming is expressions, but we're going to circle back. These are containers. They define the start and the end of something. So whenever we see one that has a beginning, we're going to know that somewhere else there's another one that is facing the other direction that is its end. They always come in pairs. So there's two right there, there's two right there, there's one right up here, there's one right down there. For every opening, there's always a closing. And a lot of mistakes for beginners is to write an opening and either you put the closing in the wrong place and everything gets kind of broken. Now this update function is inside of my start function. Very strange. Or to not write an opening or closing statement at all. So the curly braces, for every opening, there's a closing. Your parentheses, for every opening, there's a closing. And your square brackets, for every time there's an opening, there's always a closing. So those always come in pairs. Our next sort of fundamental piece of programming is an expression. An expression is a single instruction that we give a computer. A single instruction almost always is a line, it does something, and then a semicolon at the end of the line. So there's two types of code. There's like organizational code, like declaring our classes and loops and so on. And then there's commands that we tell a computer that it can just do now while the code runs. And those are things like calling a function or declaring a variable. And those almost always end with a semicolon. Here is an expression, it is over. Here is the next expression, it is over. C# does not care about line breaks. You can put all your code on one line. Python users in the audience, I apologize for this, this not safe for work images you're seeing in front of you. Look at this. This is perfectly valid code. This will compile. C# doesn't care about line breaks. It gives line breaks to you, the human, to use with however you see fit in order to organize your code in a nice and easy to read way, whatever you want to do. Line break is a character, like an M is a character, space is a character, line break is a character. It gets rendered visually as a chunk, but in terms of like this file is a stream of ones and zeros, it's just another set that represents a character. So if we put a line break like in the middle of something, it's probably an invalid character for a variable name. But a lot of the time in C#, it's just going to skip over it and ignore it completely. All right, time to fix this file. Let's just reformat the code. There we go. Thank you, writer, for doing all my line breaks for me. Okay, so we write expressions, we write definitions, we write curly braces, all of that to help C# figure out what's going on. C# doesn't care about line breaks, but we humans sure do, and we like to use line breaks nicely. We'll get back to that in the future. Let's make this thing do a thing. We have a script. It is attached to the player game object. I have a player. I have created a instance of this component on this game object. I've written my code. There it is. On the player, I've put it there. I can also put it on the floor. I can also put it on any game object I want. I've created 3 different, you might say, instances of the script. So when I'm writing this code, you have to remember that we can't specifically say move the player. We just have to say move myself. And excuse me. We can't specifically say move the player game object. This code that we're writing is just like a blueprint. It doesn't know anything about your scene or your game. It only knows about itself and things that we tell it. So we are writing it in a way that's ambiguous of the specific game, right? So I'm writing a script for player movement that I can attach to any game object, and that game object will move in the same way I want my player to move. And to make sure that to remember that we're writing code that little bit abstractly is important. So I can copy this code to a new project and put it on something. So in order to make this player move, we are going to use these 2 functions that Unity has already written for us. They're called event functions. We'll get into that in the future. Well, the basics of it is I do need to go over now. They are 2 functions that call code that Unity executes as Unity sees fit. Right? We can write our own function. Void make me a pancake. We can write our own function with a return type of no return type. It's not returning anything, also known as void. But nothing's going to run or execute this code. It's never going to happen. It's never going to make any expressions that are contained and wrapped up by these curly braces. They're never going to happen, right? Unity has to make them happen. And we use event functions to sort of start the process. So the first function I'm going to teach you how to write is the Debug Dot Log Function. If you don't see these autocompletes showing up, head back to, if you're a student, just email me and I'll help you get sorted out. But head back to that install guide and make sure you got your IDE correctly configured, because it's super helpful to have those. So debug.log, it takes almost anything. You can pass almost any object data into here. But the one that's most useful is to pass in a string. And a string we use double quotes for. I'll circle back on variables in a second and go over that. Debug.log, this is the start function. And debug.log, this is the update function. Also, whatever. Functions are also called methods. I'm going to use these terms interchangeably to the annoyance of programmers the world over. But not to the annoyance of C# programmers. Okay. So our player movement now has these functions. We're going to open our console, and we're going to take a look at what appears in our console. The debug.log is a function that will spit the messages that we have into the console. And I can leave play mode. So what we got was the words, this is the start function, and it appeared once. And then we got the word, this is the update function, and it started happening over and over and over and over again afterwards. And you might see it as this. You might see it as like a number here with this collapse checkbox. But same thing. First there was start, then there was just the words, this is the update function, happening over and over and over again. Let's clear the console and head back and think about what that means. Unity has a game loop. It's executing code once per frame, and it executes all of the functions that it needs to run, and then it renders that image into renders everything that happens into an image, plays the appropriate sound, whatever it's doing, spits that into your face as an image, and then your computer displays it on the screen. And it does that every single frame. Unity actually runs a lot faster than the frame rate of your monitor, probably, or slower, right? It can vary. And different computers will run at different speeds. So we can see what my various frame rates are. My rate is almost 500 frames a second, right? So now how I got, I was running for about 500 frames a second. It's about 2,500 frames. It was about 5 seconds of the game running there. Yeah, that makes sense. That's a lot. That's a lot faster than, I have a 140 hertz monitor, right? So it's not always displaying, it might run 4, 5, 6, 100 times, or not even once during the visual update of your monitor. It's important to know that there's that disconnect. Because often, especially when we introduce Unity, we just tell you to think of Unity as like a movie which has one frame, and every frame you do something, and the next frame you do something, the next frame you do something, and it's like showing up on your screen at 30 times a second or 24 times a second like a movie does. And that's true and a great way to think about it, but it sooner than you would expect just starts tripping up beginners for strange who just like that conceptual model's a little bit off. So I want to highlight that the frame rate is actually independent of it creates a new render for the game to have, and that render is picked up, it's put into this like what we call buffer. We just put a new one there as fast as we can, and then your monitor just grabs whatever the most recent one is when it's displaying the next frame. So the update function is code that happens every single frame, and the start function is code that happens once at the beginning of the object's life, which almost always is the beginning of the game, or when the scene is loaded. And we're going to use these functions. So we can delete that. We're almost ready to write code. Now we need to make a variable. There are two types of variables. There's data variables, and there's reference variables. They are conceptually different. One of them is a pointer. There's a keyword. But in the syntax in C#, we declare them the same way because they're just a variable is a variable. Whether you're holding a reference to something or whether you're directly holding some data, we declare them the same way. And we declare them with a very short syntax. I'm going to go over this very quickly because there's a guide for it online. It's going to be our scope, then a space, then our type, then a space, then our variable name, then a semicolon. And you can see this is errors because that's all incorrect. Our scope is either private or public, and it's private by default, so we actually don't even need to type that part. It'll just be private, but I'll type it out. Our type is our data type. So some common types are integers, which are whole numbers, floats, which are decimal numbers, booleans, true or false. Sorry, this is like my scaling is such that like my autocompletes are like taking up half my screen, and it's very distracting. Private string, sentence, private character, it's a single letter. We use single quotes to define a character and double quotes to define strings. Many languages treat these interchangeably. C# does not. C# uses single quotes to say that's a character, double quotes to say that's a string. Frankly, it's kind of nice. You just look at it and you know that's a string. That is a single character. This is a list of characters that only has one element in the list of the character A. Those are very different things as far as C# is concerned. As far as me, a human, is concerned, those are both letter A. As far as C# is concerned, the list of characters that has one item in it and that what that item might be, that character, those are different. We don't use characters very often, so strings, double quotes for strings. There you go. You, programmer with experience, might think doubles sound great, doubles sound amazing. They're nice, precise numbers. And you would be right. They're great. Never use them. Never use them. Ah, they're the worst. They are the worst. They're not the worst, they're fine. But in Unity, our rendering system uses floats, our physics system uses floats, vector 3s, our position and forces and momentums, how we store data uses floats, your graphics card uses floats, game programming uses floats. Many systems built into Unity uses floats. You will be using your variables to plug them into many systems in Unity. You will need to use floats. So using a double, which is, they can represent the same values. Note the letter F there. They can represent the same values because they're numbers. There's many ways to represent a number, but we're using floats because I said so. You're not going to be accidentally casting into the wrong data type on purpose. We use integers and floats. If integers are whole numbers, if we tried to give it a double or if we tried to give it a float, it would throw an error. Cannot convert source type float to target type integer. Well, of course you can't, because there's rounding involved. The syntax, scope, type, variable name, we can set a value to that variable right with an equal sign, right on the same line of code that we declare the variable. But we don't have to. We can just declare the variable. For data variables, its default will be a default number, or whatever default value is, which will be 0 or an empty string, or I think false. For booleans, Boolean is named after somebody, so it's just a random word. Don't worry about it. It's not like some secret mathematician cabal. For reference variables, and most of the things we're going to be referencing are components. Like those built into Unity, like transform and rigid body and sphere collider. The default will be something called null, which is a data type that means there's no data here. So what's happening is a reference variable. If we have our memory, our RAM that our computer's using, and then you think of it like an Excel spreadsheet, a variable is like a row in the spreadsheet, right? It has some number and then has some value that's there. A reference variable is like where that value is pointing you to another row in a spreadsheet. So we go to the reference variable and it says, go look over there. We go over there and it says, here's your data. So if it's not pointing to anything, it's not pointing to any row, we can't type, it can't be 0. It can't be some default value. It has to mean something that means that it's not pointed to anything, and that is the word null. So null means nothing in the context of references. Void means nothing in the context of code execution and functions. 0 means nothing in the context of numbers. So null as a programming keyword. This is a null reference. It's not referencing any rigid body right now. If we tried to use it, it would be like, hey, what? I don't know what rigid body you're talking about. Point me at one, please. So those are reference variables, behave like that. Data variables, we can just plug their values in directly. We need to tell C# what type to use because C# is going to create some space in your memory in the zeros and ones, the actual bits. It's going to create the right amount of space, and it's going to give us, I kind of think of it like an API. It's giving us some way to access and read them. If I go to the place in your memory where a Boolean is stored, one bit, a 1 or a 0, and I say, I need an integer, it's going to, and for some reason this doesn't throw an error, it would go and it would find that bit and the bits that follow it, and it would return that as an integer. And that's we don't know what those numbers are. That's wrong. Something bad is happening. We got some random data. We're probably breaking things. So we need to tell C# what type our data is because it doesn't save that how to read the data with the variable. Well, it does. It tells you what type it is, but it doesn't. In the way that Python does this too, it just like handles it for you. In C#, we have to tell it what type it is and how to access the variables. This is the advantage of having the code generally execute much faster than programming languages that don't have that strict type requirements. So it's a good thing, but it's something that we as humans need to do to make the computer go fast. I gave up on the detailed explanation in the last few words of that sentence. Okay, let's write code. For our code, we want to move the player in response to player input. So we're gonna make a rigid body reference, and I'm gonna call it _rigid body. The reason I don't call it rigid body is because I get a little a warning that shows up in my inspect. Oh, I just cleared it. Player movement. There used to be a variable built into mono behaviors called rigid body, and it still exists. It's kind of deprecated. We don't use it anymore. So this hides that variable in this thing with object-oriented inheritance, which we don't have time to go over. It's giving you a warning that doesn't matter. I like the underscore for private variables because I can type underscore and then they all show up in my autocomplete. It's fine, whatever. We can call it rigid body. Your variable names should be camel case, lowercase, and they cannot start with a number. Your type names should be what their type names are. Functions and classes should be uppercase, camel case, and variables are lowercase. So I can look at a word and I know if it's referring to a function, a type, or a variable by either the context or by the presence of parentheses or by its capitalization. Okay. Time for another function to learn. This is in a function in the input class, and this function is the getAxis function, and it takes a string, and we're going to type with a capital H. We're going to type horizontal. So we got to make sure we get our capital H run. Now this is going to return some data to us. It's going to return a number. I can hover my mouse over it, and I can see that it is returning a float. And it returns the value of the virtual axis identified by axis name. If I don't see that, I could always go to the Unity scripting API by going to help and then scripting reference, which will open it locally on my computer. And then I can type, I could probably paste because I probably copied it, the function name, and I will get the documentation. Writer is pretty nice. I have Control Q with my IntelliJ keyboard shortcuts, and then I can click that, and then it will open it up directly, which is fast. So it returns the value of the virtual axis identified by axis name, and it's going to be in the range -1 to 1. And I can set up and view my input axes by going to Edit Project Settings, Input Manager. Hey, look, I'm learning about Unity by reading the manual. Hint, hint. Nudge, nudge. Okay. Let's type debug.log and wrap a debug.log statement around. So whatever value this is returning, it'll spit it into our console, and it will do that every frame because this code is going to get executed every frame. And I should see the word 0 appearing. Turn off collapse. I can just see the word 0 is just spamming. If you don't see that, you may not have the player movement script attached to a game object. We need to make sure we actually have, an instance of our class in the scene declared. If I hold down the left arrow key, or A arrow key, it becomes -1. If I hold down the right arrow key, it becomes 1 and 0. And if I had a joystick plugged in, the left and right movement of the left analog stick would do this as well. Notice it doesn't become 1 immediately or -1 immediately. It kind of slides there. It's sort of simulating a joystick moving, which is often not what we want, but it'll be fine for us for now. So this is turning my input from my keyboard, the A and D keys, the arrow keys, and my joystick, and it's turning it into a number. I can use this function to get that data as a number, and numbers are super easy to work with in code, and that's excellent. So we are going to make a variable, not a private, we're going to make just an integer, and we're going to call it horizontal, and we will plug, sorry, a float, what am I thinking, a float, and we will plug our axis value right into that. We will then do exactly this line of code again, but we're going to do it with vertical. Vertical. And that does the same thing for W and S and up and down. So now I have these two numbers that represent the position of my input, my joystick. I need to turn these two numbers into, that are these two separate variables, into one variable that's going to represent the direction that my input is in. And we use a very specific type of data when we are storing directions. And the type of data we use is called a vector3. This is probably going to be your most used data type. It is a struct, which is something we actually haven't seen yet, because we've seen classes and we've seen literals and we've seen data variables, whatever they're called. It's a struct, which means it's a container for data, and it has some subvariables. The subvariables that a vector3 has are x, y, and z, and it has three floats: a float value for x, a float value for y, a float value for z. We can store all three of these variables inside of one variable, that we can give a name and use however we like. So if I create a vector3 with a name, I can then grab its x float value, its y float value, or its z float value. It's giving me an error because I haven't created the variable yet. So to create a vector3, I make the word vector3, I type direction, I make an equal sign, and then I have a different syntax for structs than directly data. I can't type x equals x, y, I can't type 3 bits of data at once. I need to use we call it a constructor. I need to call a special function that the vector3 class has, blah, blah, blah. I need to memorize the following syntax and use it a bunch, and then we come back and then we'll learn more about it. It's the word new, then a space. It's the name of our data type, our struct or our class, actually the same syntax. Our parentheses. And now I have actually created and run whatever creation code this data structure might have. There are multiple constructors. There's one that takes no properties and gives me a vector3 with all the values of 0, 0, 0 from my x, y, and z. There's another one that takes an x, y, and z float values just plugged right into the parentheses, separated by commas, just like a function call, which I'm assuming you've kind of seen before, maybe a little bit. This x colon is writer popping up and telling me the name of this parameter. It is not, you don't need to type x colon. You don't need to type that. I think you can. So we have our x, y, and z values to create our data. Now, you're probably already familiar with a vector3, but only in terms of how we've been using them to store our position and to store our scale and something rotation, something. To edit our rotation. we don't actually store it as a vector3. Store it as a quaternion, not important right now. So we can get a look at our position, our x, y, and z values here in the inspector. So I want my input to roll my ball left, right, and forward and backwards, which means I actually don't want to use x and y. I want to use x and z. I don't want to do anything with my y. Because I don't want to add an upwards force on my 0, 1, 0. I don't want to add an upwards force. I want to roll my ball left, right, and forwards and backwards. Y is up, so I care about that forward and backward axis, that blue axis, that Z. So I'm going to take horizontal, and I'm going to plug this value into my direction. I'm going to take vertical, and I'm going to plug that into Z, right? So it's going to be horizontal, whatever that value is, this frame, comma, 0, comma, vertical. And now I have a direction, and we can take a look at it. I have a single variable that is, I've taken these multiple inputs and turned them into one single variable called direction. And I push left, I go down, I push left and up, sorry, I'm pushing the E key on my keyboard, not the W key. I can push 2 buttons down, and you can see I get -1, 0, 1, or 1, 0, 1 if I hold down W and D. And that's just one variable. I've combined this data into a format that makes it much easier to use and to trade around and to do math on and to give to other functions, right? My input is conceptually one thing, so I've stored it conceptually in one place as one variable. I am not storing my input, one thing, my player's current input, or my player's current direction, as 2 variables, as horizontal and vertical, that I need to keep together and move around together. It's very easy to lose that context, right? I keep everything kind of contained together. Abstractly, this is a very important part of programming and Unity development honestly, sometimes it feels like half of Unity development is just finding the right representation for our data that makes it easy to work in. We want to make life easy for ourselves. All right. We have this rigid body up here that's in the private scope. We're going to change this to public. And you don't need to follow this part, but I'm going to also public int color, public int number, public color, public string. I'm going to make some other public variables. I'm going to delete those in a second. I'm just going to prove a point here. When I make something public, look up here. My word number has appeared, and it's now a whole number. I can't put any decimals. That's an integer. I have a color selector. Don't forget the alpha that I can change. I have some words. And I have a rigid body thing that wants me to stick a rigid body in this area. I'm on the floor right now. Whoops, I'm on the wrong object. Well, and a little slot where I can put a reference to some other component that exists somewhere else. Not on this game object, it's the floor. I'm in the wrong place. Go to my player, add player movement. Hey, look, my own scripts appear. And I have a rigid body. I can drag this rigid body into that slot. So now, and let's say I did have player movement on the floor. This script, as I write it, there's one instance of it somewhere that has the player, and it has a reference to the player's rigid body component on the player script. And there's another instance of the script that has this script, and it is using this variable, and it's has the rigid body is null. And if I had a debug dot log, it would appear twice in the console. Let's take it off. I don't want to show you incorrect code. I was going to prove a point, but I think it's better to not put the wrong thing in front of you. Some of you might be paying not a lot of attention to the words I'm saying and might just be kind of copying the things I type, and that would be a mistake. Okay. So because I was able to serialize this, make this visible in the inspector, and then now I could assign this value. It was null, it wasn't equal to anything. Now I can tell Unity the inspector to make it equal to something, make it a reference to this component. I can now start using this. And I can use a function that this component has called the add force function. So I type the name of my variable and then a dot, and that dot sort of steps inside of it, and I can type the add force function, which will add a force to my object, and I can give it a force of direction. This function takes a vector3 as a data type that I can pass in. As an optional second data type, ignore that for now. It takes a data type of the force I want to apply. So not only was it very nice to store my input as one thing and have that conceptually be what it is, I also needed to do that in order to give it to my add force function. So now in Unity, if I have this rigid body player here, and again, that's dragging and dropping, I should be able to hold down left and right, and my player moves. We did it. We're not quite done yet, but we're almost done because we made it work. The thing that we're missing is if the player doesn't move very fast. I want the player to move a lot faster. So we're going to make a public float called movement speed. That's going to store a number. What number? I don't know. I have no idea. And we're going to set our direction to be equal to whatever it is currently equal to multiplied by, right? Plus, minus, division, asterisk is multiplication, multiplied by our movement speed. It's kind of unnecessary to write this line of code out. We can just do that right inside of rigid body. We'll make a new vector 3 that is equal to the x times the movement speed, y times the movement speed, and z times the movement speed. Whatever that is, you know, if it's all zeros, it'll be 0. Whatever that is, will be here. So let's go back and test it out. And we're going to discover an error. Our player doesn't move anymore. Why doesn't our player move? Well, let's take a look at our player. Its movement speed is 0. Anything times 0 is 0. So my input is left. -1. -1 times 0 is 0. Hey, add a force of 0 to the player. Every single frame, 500 times a second, we are adding a force of 0 to the player. So it doesn't move. Let's set that to 10. Woo. Great. Now take a look at this variable, movement speed. It's set to 10. I'm going to leave play mode. It jumps back to 0. Why is that? That is because Unity does not save any changes that happen in play mode. And it's very easy to enter play mode and say, okay, well, let me try 2. Does 3 feel good? Maybe a little slow, maybe 5. Yeah, 5 feels all right. Great, I have the perfect value. Leave play mode. Oh no, I lost it. I can't remember it at all. Right, very easy to make that mistake. But I have a solution for you, and you've already seen my solution. And my solution is not project settings, is preferences, colors, play mode tint. Play mode tint. I like to make mine tint like a reddish, pinkish. I don't like red, like it to be too red because it's like error, something's wrong. But I notice that my editor turns pink, and I go, that's play mode. That's in play mode. I'm going to remember that. So there we go. Lastly, this camera view isn't very good. It's not a very good look at the player. So we want to move our camera. We want to make the camera look down the blue axis, right? If I move and rotate my camera to the side, I'm going to have a very interesting problem, which is if I push the up arrow to go that way, away from the camera, it goes to the right. And that's because I am adding the forces to the player in world space. I'm adding them in line with the Z and X axis you can see in this gizmo up here. So I want my camera to be looking down the blue axis, which is the default, down that Z axis, so that when I push W, I go away from the camera. When I push S, I come towards the camera. I push left, I go visually left. Right, I go visually right. If I had this the other way, then the left and right would be backwards. The second thing I want to do is I want to line my camera up a little bit further out. I kind of want to put it where my current scene view is. Well, I can do that by moving my scene view where I want it to be, selecting the camera, going up to the game object menu, and choosing these very useful nifty functions, choosing the align with view function. And now my game view my camera has been moved to wherever the scene camera is, and it's been rotated as well. And now I have my rollerball game. And that's it. That's all we're going to do today. So we are creating a public well, that's not it. We have one more thing. We really do have one more thing to do. We really do have one more thing to do, which is to clean up our code. But we have created a reference to a rigid body. We've created a public editable variable that I don't know how fast the player should go. Maybe I want one player to move fast. I want maybe one to control another one that moves slower. I don't know. Let's just let Unity handle changing those settings. And I'll just take whatever those values are and use them. We've taken input, we've combined them into a useful variable. We plugged that variable into a function that exists on a different component in the physics system. Pretty great. We just have one more thing to do, which is it is annoying to drag this rigid body onto this slot. It's annoying because this rigid body, this player is attached to the same game object, the same player game object. You know, we could duplicate the player. We'd have two of them. It's attached to the same game object that the script is attached to. Shouldn't it just know what components it has, what its sibling components are? And the answer is like, maybe. We can make that happen using a little bit of code, a special function called the getComponent function. And you might have auto-completed and had it look like this. This is wrong. GetComponent has a very special syntax. It is a type generic function in C#. It uses these pointy brackets that we put a type in, type like float or rigid body. We can put that in there. And this whole thing with the pointy brackets is the function name. So then, of course, we still need parentheses at the end of the function name. This is so that C#, no one had to write a get rigid body component, get transform component, get player movement component, get whatever component, get whatever component. It didn't have to write 8 million functions. We could just write one and they can work no matter what the type is. So this get component function will look on the game object for a mono behavior that is the same type as this part of the function, and it will return it. So this whole thing will become a reference to a rigid body that exists on the same game object that this class that's calling it exists on. And it will be a reference to that rigid body. We can take that reference and plug it into this reference, this variable, and store it. And now, if I look at player movement, I make that null, I hit play, in start, boom, it'll become equal to this rigid body. Let me delete my second player. Because this is on the first frame of the game. Before we use it, start happens before update, we will assign it. I can now make this private. Unity Inspector no longer has access to the scope. I got other lessons on scope in the future, but it is now hidden. It happens automatically. It happens for me. I don't need to see it. I have player movement. I have movement speed. Brilliant. I only can see the things that I care about editing. I don't have any like rote, grunt work. And now I have a nice player movement script to move my player around. That's it. So honestly, type generics are a pretty advanced C# feature, but we use them in one of the most common Unity functions that we ever write in code. So deal. We'll be going over them eventually. I don't know. So you can just memorize this getComponent function and use it. Great. All right, that's all I want to cover. Goodbye. You did it. You did the rollerball. Feel good about yourself.